Hello dear student, myself Vikash Kumar. Today I am going to teach thermodynamics, numerical problems, and type 1 problem is problems based on heat of formation. So initially we will discuss about what is heat of formation. Now what is heat of formation? So we can easily understand whenever after chemical reactions two reactants are combined, a product is formed. So after due to combination of two reactants, one product is formed. There's some amount of heat or energy released. So this is called heat of formation. The amount of heat is called heat of formation of product. Okay. Now we can easily understand with the help of example of whenever solid carbon react with 2 mole of H2, then a methane is prepared. After that 17.84 kilocalorie amount of heat release. So we can understand whenever carbon solid react with 2 mole of hydrogen gas, and 1 mole of methane gas is prepared. After that 17.84 kilocalorie amount of heat release. So heat of formation delta HF value in standard condition minus 17.84 kilocalorie. Now I am going to start problems based on heat of formation. This question from thermodynamics. So watch my video carefully. Now initially we will discuss about question. What is question? Calculate the heat of formation of methane. Calculate the heat of formation of methane from the following combustion data. According to given data of combustion, how we can find heat of formation of methane. So initially we can write value of delta H, okay, for combustion of methane. Here data is in positive form. Now all reactions are exothermic, so data becomes change. Value of delta H for methane due to combustion is minus 212.8 kilocalorie. Okay. Now value of delta H plus hydrogen for 2H2. So for 2H2, we can write again minus 136.64 kilocalorie, and value of delta H for 1 mole of carbon combustion data is minus 94 kilocalorie. All combustion data in given these data become change in negative form because all are exothermic reactions. Now we can calculate heat of formation of methane. Now the molecular formula of methane is CH4. So methane is formed by the combination of 1 mole of carbon, 2 mole of H2. Formula of methane is CH4. According to this question, we can put these values. So value of delta H for carbon minus 94 plus for 2H2 value of delta H minus 136.64, and in other side value of delta H for CH4 minus 212.8 kilocalorie. Okay. Now we can find value of delta HF 94 plus minus 94 plus minus, so minus 94 minus 136.64 is equal to minus 212.8 kilocalorie. Now minus 94 minus 136.64 plus 212.8 kilocalorie. Okay. Now after sum, we can get here minus 230.64 plus 212.8 kilocalorie. Now after some minus 17.84 kilocalorie is answer. So now question is completely solved here. So we can write here 17.84 kilocalorie. Now we can take a screenshot of this question is solved. Now this is next question of thermodynamics. This question is also based on calculation of heat of formation. So watch my video carefully. Now calculate the heat of formation of acetylene. What is acetylene? Molecular formula of acetylene is C2H2. Okay. From the following data, according to this question, these combustion data are given, and with the help of these combustion data, calculate heat of formation of acetylene. So initially we will discuss about 2 mole of carbon atom react with 1 mole of H2 gas, then acetylene gas form. Okay. Now according to given data, all are combustion reaction, all are exothermic reaction. So value of delta H and delta H here sign is become change for 2 carbon, for 2 not 2 H2, here single 1 mole of H2 is available. So given for 2 mole of H2, here 1 mole of H2 is required. So for 1 mole of H2, so here value of delta H for 1 mole of C2H2. Now initially first, now we can change here sign. Sign is due to exothermic reaction minus 1,94,000 calorie. Value of 1 mole of H2. Here 2 mole of H2 is given. So minus 1,36,000 calorie is divided by 2 and 68,000 calorie, minus 68,000 calorie. Okay, minus 68,000. And for acetylene, here minus 3,40,000 calorie. Now according to given these data, we can calculate heat of formation of acetylene. So once again we can write 2C plus H2, C plus H2, 1 mole of acetylene is formed. Now here for 2C minus 1,94,000 calories given, plus for 1 mole of H2 minus 68,000 calories given. In RHS side we can write minus 3,40,000 calorie. Now we can find here value of delta H. Okay, heat of formation. Okay, now minus 1,94,000 plus minus 68,000, and here plus 3,40,000 calorie. So 0 and 0. After that 1. 2,62,000 minus 2,62,000 plus 3,40,000 calorie. Now after sum we can get plus 78,000 calorie, or 7 plus 78 plus 78 kilo calorie. So this is answer. Now you can take this screenshot. This question is solved right now. Now I'm going to solve question number 3. This question is also based on heat of formation. Okay, calculation of heat of formation. So according to this question, heat of combustion of carbon and carbon monoxide CO are 94,300 calorie and 68,100 calorie. Okay. Calculate the heat of formation of CO. Now according to given data, we can find here. Now one by one we can find here. According to this question, by the combustion reaction, given that combustion of carbon, by the combustion of carbon, C plus O2, CO2, by the combustion of carbon, CO2 is formed. After that, by the combustion of CO, half mole of O2 is required. Again CO2 gas is formed. Now their combustion data we can write here. For combustion of C plus O2, CO2, 94,300 calorie, and for combustion of carbon monoxide, CO2, and 68,100 calories formed. Okay. Now for the calculation of heat of formation of CO. So CO is formed C plus half O2 CO. Okay. Delta H, value of delta H for carbon and carbon monoxide. Carbon is minus 94,300 calorie. CO is minus 68,100 calorie. Okay. So we can solve with the help of these equations. Value of combustion of carbon is heat of formation minus 94,300 calorie, and in RHS side we can write here. For some time we can replace delta HF, and value of delta H for CO minus 68,100 calorie. Now value of delta HF minus 94,300 plus 68,100 calorie, and after calculation 200 and 26,200 calories, correct answer. So we can observe easily, this is the question. Now this question is also based on calculation of heat of formation. This question comes from thermodynamics. Now from the following data, the heat of combustion, find the heat of formation of methanol. These data are given. So according to this question, from the following data, heat of combustion, okay, are given in these equations, and find heat of formation of methanol. So what is formula of methanol? Methanol is CH3OH. Okay, this is the molecular formula of methanol, and 1 mole of carbon. Okay, this is methanol, CH3OH. So 1 mole of carbon, 3 plus 1 4, so 2 mole of H2, and due to presence of single oxygen atom, half mole of O2. These species react together and methanol is formed. Okay, minimum. So according to given data, now we can calculate value of delta HF, heat of formation of methanol. Now delta H for carbon, plus due to presence of 2 mole of hydrogen, here given value is delta H is the value of delta H for 2 mole of H2 plus value of delta H of half mole of O2. and value of delta H of methanol. Okay. Now with the help of these data we can calculate value of delta HF. So okay, now one by one we can put here value of delta H for carbon atom. So carbon atom is here minus 394 kilojoule plus for 2H2 2 into 286 kilojoule plus no any data is here, value of half O2 is not present. So in RHS side value of delta H for methanol is according to given data minus 726 kilojoule. Okay, we can write here kilojoule. After that minus 394 plus. Okay, now we can check once again 286 is also in minus, so minus is here, so plus minus minus and 6 to 8 568 plus 726 kilojoule. Numbers minus okay 962 plus 726 kilojoule is equal to minus 240 kilojoule. This is answer. So you can take a screenshot. Question please right now.